All right, thank you guys for coming. For those of you who came or those of you who are viewing the recording, thank you guys for coming. We have an exec-led presentation today, going over nutrition and exercise and how they can be related. So I'm just going to pass over the mic to Dominic to kick things off. You should be able to share your screen. I do have it enabled.
All right, cool. Let's see if it works.
Drum roll.
All right, can you guys see that?
Yes.
Wait.
Yes.
Oh, do you see the, okay.
How cool.
I'm gonna do presenter. All right, wait. All right, perfect, cool. Okay, hey everyone, my name is Dominic, and this month's theme is nutrition. So, I had to look up an article on that, and I could have gone the traditional route, right? I could have done like, oh, whey protein, supplementation and stuff like that, and exercise, but I didn't. And I stumbled across this article having to do with eggs. And who doesn't love eggs, right? You can make an omelet, you can boil them, can right? So okay, and then basically they figured out the same thing. So it's basically, if I were to do a whey protein supplementation article, except just with eggs. So yeah, they subjected them to an exercise protocol, and then they looked at its effects post workout. And here they compared whole eggs versus egg whites. And yeah, so basically they wanted to test the whole food sources of protein, such as eggs, instead of supplements, because it would resemble more closely to a normal diet. And basically, after a short exercise protocol, the researchers wanted to test for the differences in leucine concentrations, which is an essential amino acid, which can only be obtained through our diet. And they also tested for myofibrillar protein synthesis after consumption, which is basically, how we recover, how we grow our muscles. They checked for those rates after consumption. And basically their hypothesis was that the whole egg group would have greater concentrations of amino acids after consumption, but it would appear later in circulation due to its fat content from the yolk. But overall, it wouldn't affect the amino acid concentration and myofibrillar protein synthesis over the 300-minute observation. So that's something to keep in mind. And yeah, so here's the experimental design. Basically, they use 10 trained males, and they're split into two groups, the whole egg group and an egg white group, both 5 individuals each. And they underwent some baseline testing. And this involved measurements for the leucine content in their blood and baseline myofibrillar protein synthesis rates. And they did this through muscle biopsies. They did muscle biopsies in their leg. And they also did like an infusion thing. That this got pretty complicated. But basically, they also wanted to test for other muscle protein synthesis factors that I'm not going to present in this presentation because just wanted to nail the head on what they actually wanted to test for. But yeah, so basically after the baseline testing, they went through an exercise protocol, and this had to do with 4 sets of 10 repetitions on the leg press and leg extensions. And this is controlled for both groups at the 80% of their 10 RM. And then immediately after the exercise, they consumed their respective eggs. And then after, they went through the same testing over this time 5 hours or 300 minutes. And yeah, just going back to this slide, I wanted to highlight the 2 groups, and they're getting similar protein amounts. So the whole eggs, I think the whole egg group, they ate about 3 whole eggs, and then they made a egg white concoction of the same amount of protein. But obviously there's a little variance in the leucine concentrations, but it really didn't have a whole huge difference for the results. And then wanting to note here, obviously with the whole egg, you have the yolk, which contributes fat, which then contributes more calories overall. So that's something to keep in mind throughout. And yeah, so we get into the results now, and I just chose some data from theirs that I thought was important to highlight, especially for this, their main goal of this research. And basically with the exogenous leucine, which is coming from what they consumed, right? So basically they found that after 75 minutes post-consumption, they had a greater concentration of exogenous leucine coming from the egg white group. And this is fairly recent after they consumed it, 75 minutes. And but over time, we see that after 300 minutes, the whole egg group had greater leucine concentrations. And then when it comes to the graph on the right, we see the myofibrillar protein fractional synthesis rates, right? After 300 minutes, so the entire data collection, after 5 hours, we see greater rates, greater percentages at, with the whole egg group, right? And other than these differences between the group, the overall leucine retention was similar over the 5-hour observation. So basically saying that the exogenous leucine concentrations were pretty much not really that significant. And yeah, so we get to the discussion, they saw that the exogenous leucine concentrations, although they were varying amounts during the different times, so like we saw the acute rise in the leucine in the egg white group, it really didn't have a huge effect on the overall muscle protein synthesis post-exercise. And then, but they did see a significance with the myofibrillar fractional protein synthesis rates, right? So we saw a greater amount, I'll go back, we saw a greater amount in the whole egg group compared to the egg white group, and this was significant. And this basically suggests that you know, whole foods are more nutrient dense, and this has some correlation to the greater muscle protein synthesis rates, right? So why even remove the yolk in the first place? They might be exhibiting some, you know, anabolic effects that need to be researched more, right? And yeah, so basically in conclusion, right, what they found was that overall the myofibrillar protein synthesis rates were greater with the whole egg group compared to the egg white group. And this begs more research to be done on the non-protein contents of the yolk, because they may have some anabolic effects on those certain pathways in muscle protein synthesis. And this is mainly in part due to the reason that both groups were given the same amount of protein, and the only difference was within the yolk. And you know, the yolk has different elements such as the fats and different vitamins and whatnot. So more research should be done in that area and what effects they have on those pathways. And yeah, that's it. Thanks, guys. Here's the article.
That's like the perfect gift. I thought that was pretty interesting though, because
it was actually Sheree sent it to me.
did she really?
Put that. So yeah.
That's perfect. I was gonna say I thought it was pretty interesting because when my brother was really big into powerlifting, he was like majorly obsessed with egg whites, and I was like,
yeah,
okay. I was like, I feel like there has to be some way to make it flavorful like this to be enjoyable to eat, because I've never tried it. I've never really been inclined to try it, but
it's pretty, this has caused me to have to ditch the egg whites, because it might not be much of a difference other than the calories and fat.
Oh yeah, so it's really just that, right? It's just the amount of calories and fat that's the difference. But in terms of like
people, like the basis for this was that like, oh, egg yolks, it has so much cholesterol, and like people were scared. Like the American Heart Association, they made like the recommendations for cholesterol to be like, you know, under 300 milligrams, right? And that's basically, one egg has like 187 milligrams of cholesterol already. But I think those standards should be changed, because like it also depends on, you know, what you're doing physically, like for your physical activity and stuff. Like there's also like so many benefits to the yolk that like I think it trumps like the cholesterol, right?
Yeah.
And that's kind of like why they did the study. So yeah.
It
so I thought
me
it was
back.
cool.
It throws me back to the days of opening my fridge and seeing like 6 egg white cartons along the side of the fridge, And then my brother was a horrible cook, so when he would make them, the whole pan was just white. It's like, okay, as long as as long as you're happy, I guess.
Yep.
That's funny.
Yep. I've been there.
Well, thank you, Dominic, for that. And then I'm going to toss over the mic then to Sylvia for her section.
Mine isn't as visually pleasing, you guys. So sorry. I literally was not expecting Dom to go off like that. Okay, so mine is a little bit different. I didn't focus specifically on one study. Sorry, I'm trying to move you guys so I can see what I'm doing. Sorry. So I kind of wanted to take the approach more so on like more so of a review of carbohydrates and proteins in like different athletes. And yeah, so damn it, you guys, I can't even scroll. There we go. So basically just like carbohydrate recommendations between individuals. And I think this is like really important. And I got this specific graph from my personal training book. So I am a personal trainer. So this was like really nice to kind of just like go back and see just like the general like DRIs of what you should be consuming as like a normal adult or like an endurance athlete. They don't have strength athletes on here, which I'm kind of sad about, just excluding us. But we see here that it's a pretty good amount as we start going from like the typical like US intake. It starts increasing more so for endurance athletes. And we usually see this because obviously endurance athletes require a higher percent of carbohydrates in their diet to be more readily available for their type of sport. So they require more carbohydrates because they are burning, or you require more carbohydrates for energy in their sport. And we see kind of like for strength athletes that we don't necessarily require as much carbohydrates as we do protein, because we are breaking down more skeletal muscle than we are anything else. So I think like this was a really good just like basis on like our carbohydrate recommendations as athletes, or just like as a normal typical adult, making sure that you are still consuming the adequate amount of carbohydrates throughout your day and every one of your meals to kind of keep those glycogen levels like pretty steadily throughout your day. Some of the really important things about carbohydrates is that they're super important in fueling our brain. So our brain and our central nervous system requires glucose the most for energy. So usually like, if we haven't had like some carbs or something, we feel like pretty tired. So making sure again that you're getting those adequate carbohydrate intakes throughout your day is really important in that sense. Another thing is that our carbohydrates can allow for less of that protein breakdown throughout the day. So when you have lower amounts of carbohydrates, you're more likely to start feeding on your skeletal muscle as fuel. And we definitely don't want to do that. We don't want to break down our skeletal muscle. So that's super important to be able to have. And of course, as exercise is medicine. So if we exercise, we want to have carbohydrates for energy. We love carbs. We support carbs here. Please eat your carbs. Always. I love carbs. And then we kind of go into more so of the protein requirements, or the protein requirement intakes for normal adults, endurance athletes, and here we have strength athletes. So again, you see kind of like an increase, like a gradual increase between athletes, and you kind of see the difference here between our carbohydrate consumption between endurance athletes and their protein recommendations. It still is a little bit higher than normal athletes, obviously because they are still breaking down their skeletal muscle a little bit more. But we see now here that strength athletes require the most amount of protein. And we know this is because we are breaking down a higher amount of skeletal muscle. And so we want to be able to repair that muscle a little bit easier. And how do we do that? If you have more protein in your skeletal muscles, the more you're going to be able to use it for repair, which is really important. And the article that I'm kind of presenting is more so a review of protein. And this kind of goes into the sense where it's like, I kind of ask myself the questions, well, what about consuming more protein? You know, you always hear the question, well, can I consume more protein? Is that going to help me get bigger? And you kind of just take into consideration, well, these are the recommendations of grams per body weight for a reason. And I really like this kind of like overview. It was a huge review. It was super, super long. So I kind of picked and chose, I don't know, one of those, what was the most important and what kind of what I wanted to share with you all. So the review was called Recent Perspectives Regarding the Role of Dietary Protein for the Promotion of Muscle Hypertrophy with Resistance Training Exercise. And basically the purpose of the study was, again, it was a huge review, and it was more so on the recent advancements that we're kind of being able to understand on how protein adjustment really works for skeletal muscle growth, right after resistance training. And the specific reviews were more so studies on young athletes, and energy balance and energy restrictions. So energy balance is when we're pretty energetically level, so we're consuming good amount of calories, and we're able to use those in a balanced way. If we kind of think of a scale, a balance, so we're kind of around here. Energy restrictions were, for example, for like bodybuilders, if they were cutting, right? So now you're in a negative energy balance. You're cutting a little bit more of those calories. So they did review that as well. So one of the things that I thought was really cool, and especially with like the question regarding like, well, if I eat more protein, will it help me get bigger? So they had them ingest 20 grams of milk-based protein, such as whey protein. And we see here, the diagram kind of takes us through, right? So approximately 50% of the ingested protein goes into our splenic tissue, such as our gut and our liver, before it enters our general circulation. We see here that approximately 10% is part of the de novo protein synthesis. And this is basically just like the creation of like for fats in general. And then we have remaining approximately 40% of ingested protein is catabolized. So we see kind of like this idea where you don't necessarily need a higher amount of protein, you need an adequate amount of protein. The rest of your protein that you're ingesting is ultimately going to get catabolized, and it's going to not go into your skeletal muscles for growth. So I thought that was really interesting because, again, we kind of see like a lot of these articles saying like, eat more protein, eat more protein. Well, we can eat approximately 0.8 grams for a normal individual, and they can still see that muscle protein synthesis. The other chart that I figured that I thought was pretty cool was the timing, and this is muscle protein synthesis percent per hour at a rest and post exercise. So again, because it was a review, they didn't necessarily give us like a lot of the methods of the study, but they kind of gave like a description of what happened. So we see here, like during the rest, 20 grams was optimal for the muscle protein synthesis, and having an excess amount of protein such as 40 grams, there really wasn't much of a difference between those two. The main difference was between 10 grams to 20 grams. So we see here again, excess amounts of protein don't necessarily stimulate greater muscle protein synthesis. We can consume an adequate amount. And again, post exercise, the same thing. Yes, it is 48% compared to 35%, but still that is a little bit less than 16 to 35%. So you have to look at the relativity between those percents and see, well, I don't necessarily have to consume an excess amount of protein to be able to stimulate that muscle protein synthesis in my muscles. So that's why there is those certain recommendations. Again, we also have to take into consideration that every body is different. Depending on how much you weigh, obviously you're going to require a little bit more protein, but acknowledging that the excess amount of protein isn't necessarily going to do much for you. So just make sure that you get an adequate amount. And I really like this kind of breakdown that they provided, their practical recommendations. And so I kind of really wanted to screenshot this and provide this information to y'all. Let me see if I can get my laser. Yay! So one thing that I thought was really they just broke it down for us, right? So energy balance, making sure that you're like spacing out your meals over like a 12-hour period. So making sure you're kind of getting in those that protein throughout your day. I thought something that was really interesting, and hopefully maybe next time we'll talk about it, was pre-sleep protein ingestion. So I know that a lot of individuals drink casein. I used to drink casein before sleep. During our time of sleep is where we're repairing the most. A lot of people think that when we're exercising in the gym, we're building muscle. We're breaking down muscle when we exercise. We repair it when we sleep. That's why sleep is super, super important. So a lot of the times individuals take casein before bed, and I would do it as well as a way to help us repair those muscles while we slept. So again, it's obviously something that needs more researching, but I thought that that was really cool. And another thing that is really important for us to kind of take into consideration is for those individuals in energy restriction, specifically for weight loss, we can see, and based on the research, that higher protein diets are best for weight loss, as you're kind of curving the muscle loss and allowing to repair that muscle and grow that muscle a little bit more, encouraging muscle protein synthesis. So that was it. That was all that I have for you guys. These are my references. I hope you guys took a little bit of something on it. I know it wasn't as interesting as Dom's, but I thought it was super interesting. And you guys should definitely read this review. It is very long, but they had a lot of really good stuff in there. So I hope you guys.
Thank you.